Hello, welcome to Advanced Algebra 2. Here we are in still the 11th learning target. We're talking about one-to-one functions now, and I'm terribly sorry, but the heater is going in the background, so if you can hear that, I'm really sorry about that. We've got to talk about what it means to be one-to-one, and one-to-one is if every member of the range, so every y value, comes from exactly one member of the domain, one x value. Later on, you're going to see that means a horizontal line test, just like a vertical line test for being a function. But first, let's graph one. So we got y equals x. These are really rough sketches. I'm sorry about the lack of straight edge. But this passes what we call the horizontal line function. If I drew any horizontal line through the graph, the red graph, it would only hit it once. So it's good. So that is one-to-one. Now, y equals x squared is our friend the parabola. Zoom, zoom. Now this one, if you drew a horizontal line, boom, it hits it twice. Now yes, if you drew the horizontal line low enough, it wouldn't hit it at all. Then in one magic spot, it would hit it exactly once, I suppose, but stop being picky. Look, it hits it twice. Fails the horizontal line test, not one-to-one. All right, next example. Y equals x cubed, so zoom in. All right, if you drew horizontal lines, it hits it once. It's actually not interesting, so I didn't draw them. So, boom, that is one-to-one. Y equals square root of x. Square root graph. If you drew a horizontal line, it hits it once. This is one-to-one. Now, again, cube root of x. We did this at the beginning of the year. It's like square root, but both sides, and a little bit less vigor. Hey, if you drew a horizontal line, it hits it once only. So this is, in fact, one-to-one. Boom. Y equals absolute value of x. Our friend, the v. Boom. Oh, horizontal line, hits it twice. Shucks, folks. That one, not one-to-one. One more, and this one will end up being the most important one when we finish the notes in class. Y equals 2 to the x. Now, hopefully, by now, you got a zoom. There's an asymptote and all those business. But hey, any horizontal line hits it once only. That asymptote might be tempting, but a true horizontal line, which is infinitely thin, only hits that once. So, this is also one-to-one. Fun business about one-to-one functions. Now, inverse functions are things that you can get from functions that were one-to-one to begin with, and it is the function that undoes the original function. And later I talk about a monster that eats x and poops y, and then it gets gross if you think about it. So instead, let's do some graphs. Okay, so here we have the graph of y equals 1/3 x minus 4, and that is a thing with a y-intercept of -4 and a slope of 1/3, and there I go, and I'm sorry about the perfect straight edge. It's very hard on an iPad screen, but there's our graph. I'm missing a arrow on the left. I can fix that. Zoom, zoom. There we go. Now, let's throw down some points. There's the point 0, 4. For the inverse, that's the point -4, 0. Perhaps you noticed what I did there. Let's go again. We have this point, which is 3, -3. That means there's the point -3, 3 on the inverse. The x's and the y's are swippeting and a swappeting. Here we have the point 6, -2. So the inverse is -2, 6. See what I did there? And then we go maybe going backwards. We have the point -3, -5 on the original graph. So -5, -3 on the inverse. Oh, look, it's another line. Zoom. Okay. Good times. Looks like it has a slope of 3 or something. Oh well. All right, next example. Here we have this cubic, and I wrote fx instead of y equals just to mostly be annoying and make you used to it. So it's a cubic that's moved left 2 and down 1. So there's our cubic, moved left 2, down 1. Let's talk about points. There's the point -2, -1. So on the inverse, it has the point -1, -2. The x's and y's are just swippetying and swappetying. There's the point -1, 0. So on the inverse, we have the point 0, -1. Another 0.07, which means the inverse has the 0.70. And now we can make the same thing. Oh, now look, the original graph was a cubic, and the inverse is that's right, a cube root. There's something happening here, folks. Okay, fun with graphs is over for now. Let's do it symbolically. Okay, so we've got the inverse of y equals 1/3 x minus 4. If you look back, you'll see that's the same as the first graph example. Okay, so first step, I like to just rewrite the function. So I just, original function here. Now, we're going to go ahead and do the magic thing that makes the inverse, which is the xy swippity-swappity. I like to call it the old switcheroo. So the x and the y switch, exactly. Just wherever you see an x was a y, wherever you see a y is an x, back and forth. That's what makes the inverse. At this point, you're looking at the inverse. The problem now is that it's not solved for y, so at this point we just need to solve for y. So add 4 to each side, and then multiply each side by 3, so it's 3x plus 12. So the inverse is the graph 3x plus 12. Let's go back briefly. Boom, boom. Ooh, the inverse 3x plus, yep, I see it. Okay, moving on. Sorry, boom, boom, there we are. Next one. Okay, we have fx equals x plus 2 cubed minus 1. Now, when I say write the original, if it comes looking at you like f of x, you need to stare it down and say, look, function, you're fronting. Just write a y where it says f of x as rewriting it, and then you can go ahead and do your old switcheroo, flippity-floppity, x and y swap if you like. So to make the inverse, the x's go where the y's were, and the y's go where the x's were, so the x's and y's swap. Now we have an inverse, but we need to solve for y, so add 1 to each side. That's not so bad. Then cube root. And remember, cube root doesn't cause a problem. There's no plus or minus business with cube roots. And then finally, we go ahead and, subtract the 1, so it's cube root of x plus 2 minus 1. Now, to have good form, we write that as f inverse, which is f to the negative 1. This is an annoying notation thing because it does not mean 1 over f of x. It means the inverse function specifically. It doesn't mean the reciprocal of f of x. I'm sorry. Not my fault, but they do pay me, so you get to blame me if you want. Okay, so the inverse is what you get when you flip and flop the x's and the y's, and you go ahead and solve for y again. So then the last one is f of x equals x plus 2 squared minus 1. So we'll go ahead and change f of x into y. And excuse my lack of concentration. So one of your classmates came in and started wanting to talk on the video. Okay, so then go ahead and do the xy flip-flop. So now x's go where y's were and y's go where x's are.
Hi.
That was Katie Luperl pretending to be assertive, ladies and gentlemen. Okay, now go ahead and add 1 to each side. We're just solving for y still, and so then boom, and then finally you've got to do a square root. But remember, with square roots, there's a plus and there's a minus. Remember the quadratic formula or the completing the square thing. Most of you don't remember completing the square. Anyway, good stuff. So, but the plus or minus is a thing. And you subtract 2 because, solving for y. So negative 2 plus or minus. You could put minus 2 on the end instead of in front. Doesn't matter. But hey, look, folks, this is not a function. This is not a function because the plus or minus. So the inverse fails to be a function because the plus or minus, because you had to do a square root, because it was squared, and if you think about the fact of a graph of a squared, we're talking about the graph of a parabola that's moved left 2 and down 1, and then we're talking about this thing here, zoom, and this, ladies and gentlemen, is not 1-to-1. 1-to-1 fail, inverse function fail. but you got to try. Hey, we're going to have an assignment that's a worksheet, so it's not ready for you yet. Just watch this, get it down, and please, as always, let me know if you have any questions. Thanks for watching.